Okay, this module is going to look at some of the fundamentals of software product line. So the concepts behind software product lines and why your organization might consider taking on software product lines, and then some of the terminology that you will find in a software product line operation. So I'll talk about those things, and I'll also talk a bit about what software product lines are not. And there are many different examples of what software product lines are not, based on the kinds of confusion that we have seen exhibited by people who are trying to start a software product line, or who come to our courses or our workshops and ask us about, well, what does this mean for our organization? But for many organizations, this whole idea of software product lines had its start in trying to come to grips with software as an engineering discipline. And in particular, in our work with the automotive companies, where you have organizations that are sort of traditional old line engineering organizations with a lot of expertise in mechanical engineering and electrical engineering, and are used to disciplined engineering processes there. Then they take on software engineering, and they find out that software is becoming more and more a part of the value added in the products they build, but they are anything but disciplined, or at least they have been in the past, anything but disciplined in the way they tackle their software development efforts. And so what they are finding is that more and more of the value added in a car, for example, comes from software. In fact, there's a frightening amount of software in cars these days. But the kinds of... Pardon?
Especially if you own a Prius.
A Prius, yeah, for example, yeah. There are so many different kinds of microprocessors and so many different kinds of controls and different software applications aimed at basically improving your comfort and improving the vehicle stability and the body electronics and the whole infotainment system, that it's just staggering the amount of code that's in there. And it's also staggering when you think that in the early days, at least, much of that code was being slapped together by mechanical and electrical engineers. Mm-hmm. Things are changing, and for the better. Well, maybe. As I say, there's a frightening amount of software, and when something goes wrong, you can't just take it to Joe's Auto Body anymore. But that's another story. So the kinds of things that people are going after with a software product line approach are things like high quality, or improving the existing quality of the products you build by having this two-tiered approach of, first of all, creating core assets and then using those tested, approved, baseline core assets in the creation of multiple different products. Quick time to market has always been a big driver for many commercial organizations. We've got to get products out the door faster, and they see software product lines, basing their product releases on reusable artifacts as part of product production, as a way to achieve this goal of faster time to market. Market dominance and market agility are also the kinds of things you can achieve with a product line approach. Market agility, in particular, is appropriate for organizations that are trying to play catch-up with the big boys. So if you want to be able to move into an underserved market that you perceive has an opening for you, then being able to do that software product lines are a way to enable you to do that, because of the increased predictability that using a product line approach affords. Product alignment refers to the fact that you may have many different products in the marketplace right now, and you are trying to brand them or market them as a family of related products. And the difficulty is, especially for large organizations, is that historically those different products, even though they look as though they ought to belong to a line or a family of products, are built in different parts of the organization with no sharing of resources. They're done in the classic stovepiped or siloed fashion because of how the organization evolved as independent units. And now you're coming to a realization that, well, you may be driven to it by economics, that we simply can't afford to spend the kind of money we are spending on duplicating these efforts across the organization, because we have people all essentially doing the same thing with minor variations for different markets. So how do we rationalize that whole process and save money and save time by reusing artifacts across these different parts of the organization? That's the challenge of product alignment, or a shift towards a product line approach. Low-cost production and low-cost maintenance, of course, have always been the big promises of any reuse-based approach. And mass customization, probably the best-known example I can think of is my trusty Dell laptop. When you buy a laptop from Dell, you go to the Dell website and you go through the various options and you basically create the one you want. They have offered you a range of options in terms of screen size, memory size, processor size, additional devices like webcams. So, in effect, you put together the laptop you want and then order it from Dell. Dell doesn't have that particular laptop sitting on a shelf waiting for you to buy it. So they have a mass-produced product that's customized for you. And the way they've been able to do that is by being proactive about anticipating the needs of their customers and their markets and pre-planning for this range of commonality and variability. And we'll see that's an essential part of software product lines. Why can't we do what we've done in hardware with software? Thinking about the range of features and capabilities that you would offer to your customers and your market segments, thinking about the range of variability, the range of commonality, and how you might exploit that in the form of reusable artifacts like an architecture and components and other artifacts that would support a software product line. So you are attempting, if you're a product line organization or becoming a product line organization, you are attempting to improve overall organizational efficiency with respect to goals like these. And that's really the bottom line for software product lines. Software product lines are they're not really about the technology. They're about the business prospects of an organization and whether the business needs of an organization can be served by creating a line of products at a time instead of a single system at a time. And organizations have come to these, or have tried to address these goals in several different ways, and probably the best known way from the SEI at least is by way of process improvement. And the SEI is probably better known for process improvement than anything else, although we in the product lines group are trying to change that, and we would like to get product lines as firmly in the minds of people as process improvement is. Technology innovation is another way of trying to address the software engineering skills that you would need to become more efficient in the marketplace. You be innovative with the kinds of technologies that you put in your products, and you try to be the leader in terms of those technological innovations. And then finally there is reuse. And reuse is a concept that has been around for quite some time. And it's largely based on the idea that when you are creating products for users or market segments, that there is very often a substantial degree of commonality across the kinds of products you build. In this simple representation here, we have 3 different products aimed at 3 different market segments. And each product has an underlying set of core functionality and capabilities that's common across them. And then you have some additional variants for market segments, like the market segment that would have the enterprise edition or the professional edition. So your goal would be to address these different market segments with this range of products that are built from a common set of core assets with an allowed range of variability. And by the way, I should stress that when I talk about common software or common artifacts, I'm not talking about a one-size-fits-all solution that's going to be forced on everybody. When I talk about common software, what I really mean is that there's an underlying base of commonality, but there's also a range of variation that's the complement of that commonality. So there's an underlying core set of functionality and an underlying core set of quality attributes that crosses all of the products, and then the variants for specific customers and specific markets are the allowed range of pre-planned variants that you have incorporated into your reuse strategy. This is an example of the kinds of challenges that you will face as a manager of a reuse operation, and you can plug in your own numbers here for N and M. But you have a number of systems under development that are largely similar, but for historical reasons, they're probably being built in different parts of the organization by different people with potentially different tool sets and different levels of process discipline. And in today's economy, you probably have less money to spend, or at least the amount of money you have available isn't increasing. You probably are being required to work smarter with the same amount of people because there's a hiring freeze. And on top of that, the systems that you build are not getting any simpler. So what can you do about it? Well, software product lines and a reuse-based approach are one example of what you might do with it. If you're a developer, you are faced with a similar situation, but you may say, you know, I've worked on these kinds of systems in the past. I recognize opportunities for reuse, so I've tried to save some code. I've tried to save some designs, and of course I've got the reusable knowledge that I bring with me from one project to the next. And yet, it never seems to shorten the test and integration time. It never seems to get rid of the big crunch before a system delivery. And so the whole idea of reusing knowledge and reusing artifacts from previous projects, while it sounds as though it ought to work, in practice, it never really seems to be able to pan out. And we will talk shortly about why that is the case. But reuse, as I said, has been around for quite some time, and there's been a gradual evolution of reuse from the earliest days when it was primarily a technological, or viewed as a technological problem, up to about the mid-90s when you started to see more of a business focus being brought to this whole idea of reuse. Klemens Siepersky, the guy who wrote the book on component-based development, envisioned a third-party workplace of components where if you wanted to build a complete system, you would be able to go out into the marketplace and buy these commercially available components and assemble them together to create a complete system. And round about the mid to late 90s, I think it was, Dave Garland and his architecture students at CMU decided to put this idea to the test. So they bought a series of commercial components. And the idea with the commercial components marketplace is that these components are out there in the world. They're documented according to well-defined standards. They have published interfaces. They are ready to go. You just plug and play was the whole idea of this component-based marketplace. So Dave Garland and his students decided to try this out. They wanted to create an architect's workbench, and they bought several commercial components. They bought a GUI builder, database management system, an RPC mechanism, and there was one other component that I can't remember. And the idea was we ought to be able to create a complete system by assembling all these well-defined commercial components together. It turned out to be a nightmare because each component is built with its own assumptions about resource constraints and resource consumption. And the fact that each one individually might meet the needs of what it was designed for doesn't guarantee that when it's incorporated into a complete system that it will function properly in conjunction with the other components. In fact, what was lacking was an overall architecture to guide the assembly of these components. So without this overall guidance of an architecture into which these components can be plugged, you lose the benefits of this idea of a third-party component marketplace. So component-based development alone is not enough to get you a product line. The lack of an architecture was referred to by Garland and his students as the architecture mismatch problem. And we'll see this coming up as a kind of a recurrent theme in later parts of the course. Now we see a lot more emphasis on things like services. And again, there's a much more business-oriented focus in services than there has been in the past with some of the other technology solutions like object technology. So there's this gradual evolution of reuse as both a technical and a business proposition. And so software product lines fit nicely into this space. And all of the work that's been done, particularly in component-based development and services, are a nice complement to the kinds of things that you would be facing in a software product line effort as well. So even though SOA, for example, the emphasis is on the A word, architecture, SOA is really not just about architecture. It's really a service-oriented business. But the three-letter acronym for that is already taken in another context, so it's SOA. And also, I think because of anything that comes out of the object management group tends to have the A word on the end of it. But there definitely is much more of a business focus with SOA than there has been with some of the earlier approaches. So what has happened is there's been this gradual shift towards a strategic approach to reuse. That's a combination of a technical strategy and a business strategy. And that has laid the foundations for this whole idea of a software product line. By the way, before I talk about some of these case studies, has anybody had any experience with trying to do a reuse effort in terms of component-based development alone, or object technology, or reuse libraries, or any sort of thing? I see a few heads nodding. Mike, what about?
Prior to the SCI, when I was still in the Air Force, I worked for a radar evaluation squadron, and we basically re-engineered our radar eval tool and build it in such a way that you could scale it up or scale it down. It could be multicast information across the network. We took about 6 months just doing the design work before we started any coding, going back looking at scenarios, real-time inputs versus recorded inputs, and multitasking it. It was an interesting exercise, and it's still very much in use today. But it took a lot of thought up front.
Yes.
While I was working for this company, we were actually building custom solutions for different clients. And at some point, we decided to start building up these frameworks that will be used across different projects and do things like entity management and things in those layers. But in the end, we always there was a big incentive from the clients and from other people to keep changing and putting new technologies in other layers, and then that changed not the parts of the framework that we had designed for reuse, but the overall process in which we designed the systems, and we implemented so much that we really couldn't take advantage of that reuse that we had in some places of the architecture. Very problem.
Anyone else?
We use a lot of reuse in our industry. Basically, we are a multi-channel company where we have brick operations, which is retail, physical retail, and then we also have internet channel. We have also direct marketing channel. So all three components are pretty much as kind of initially it was separate lines where we are more focused on catalog retailer than on retailer. So we expanded the market on the retail side, and geographically in our U.S. So then we started reusing the components. Some not work because it's driven off of the catalog methodology there. So kind of challenges we went through. But now we are true multi-channel company, so we are giving an equal weight on all these three channels. So we're trying to manage through that way.
So you're reusing at the multi-channel level instead of trying to
do the
tailor or hack a specific channel for reuse across the others.
Yeah, we start off with the catalog company, and all our applications are designed in such a way that to support the catalog. Then we venture into the retail, and initially retail became a small entity in the larger organization. Then more and more expand. Now we are more retail company then. So then the internet is another part of the business segment that we have. So we got to combine all three, and then we tuned our system to support multi-channel. So that's become a big challenge there.
Anyone else?
Because I'm an independent consultant, I change projects quite often. But I've seen companies, like one of them was Daimler-Benz, who were trying to build reusable components, and they were always suffering from like the fast move of the technology they wanted to build on. Like they started with building reusable components for the business kinds of applications in Smalltalk, then moved on to Java, and then there's another Java Enterprise, and the next iteration of it changes a lot again. So it's a lot of running behind the technology, which seems to make it very difficult.
Yeah.
From a technological point of view.
Yeah, it's hard to incorporate that. If you're trying to play catch up with that, it's hard to stand back and say, we need to look across this portfolio of products that we're building, and we need to make some decisions about the technologies and about the processes and the business justification for treating these as a line of products or as a set of services or whatever approaches. I'm not saying that, because you're in the product lines course, you have to now treat everything as looking like a product line. And in fact, even if you don't get as far as creating an actual product line, there's still a lot of, we believe, good information in the framework that would allow you to become more disciplined about your technical and business processes, whether or not they end up creating a product line. Here are some vignettes of organizations that have been successful with software product lines. Our earliest success story in product lines that we are aware of is Celsius Tech. Celsius Tech is a Swedish defense company. They make shipboard command and control systems for Scandinavian navies. And at the time that they got into software product lines, which was it had its roots in about the mid-'80s when they were awarded 2 large contracts simultaneously, something that hadn't happened before. So up to then, they had a history of always delivering on time and late and over budget. And they were constantly taking what was done for one customer and tailoring it for the next customer. And then when these 2 simultaneous contracts came along, they realized we're going to have to stop doing things the old way. This idea of taking something for a Swedish corvette and trying to create a shipboard command and control system for a Danish frigate or whatever it might be just wasn't going to scale. And so they started to really think seriously about how are we going to manage these 2 contracts simultaneously. And in fact, we're probably going to get more of this in the future. So we need to start thinking about tackling a line of ship systems at a time and get away from this successive tailoring of previous efforts. So they reorganized around this whole idea of an architecture and a set of reusable components to support multiple ship systems. And these are the kinds of results they've been able to achieve with what is now known as, or what then became known as, Chip System 2000.
Wasn't Celsius Tech also one of the early ADA success stories?
Yes.
They were winning like 80-90% of the contracts they went out for once they reorganized that.
Yeah, I mean, it was a huge change for them, not only from the point of view of creating a product line, but they were moving from a mix of assembler and RTL into the world of the Ada programming language. They were moving from what I would regard as a set of point solutions around the ship to a fully integrated networked approach to command and control. And there were many artifacts that they ended up creating that we now take for granted, like GUI builders and so on. So they were really the pioneers. And because they were the pioneers, this took almost 10 years and several changes of management before Ship System 2000 became a routine part of the way they operated. Nowadays, with so much more information available, your time frame for adopting software product lines is much shorter. But these guys were the pioneers. Cummins, which we will hear more about in the case study, they created a product line of integrated engine management systems for diesel engines. It started off in the automotive group, but based on the success of the work that they did within the automotive group and based on the pre-planning and anticipation of future business, they were able to go after the industrial market as well as the automotive market with this product line approach. The control channel toolkit. Control channels are what they call these paths of communication between a satellite and a ground station. So the control channel toolkit is a core asset base for a software product line. The National Reconnaissance Office awarded this contract to Raytheon. Raytheon would build the core asset base, and then the plan is that future reusing organizations that get the full satellite command and control, both the ground segment and the space segment, would take this reusable control channel toolkit and use that as the basis for creating the ground station software. Market Maker is a small, or at least at the time of the case study, a small German company that makes stock market tracking software. So they began in the days of DOS-based PCs. They were going after individual investors where you would load the Market Maker software onto your PC and then you would get weekly updates to your portfolio on a floppy disk, and you would use Market Maker software to see how your stocks were doing. Well, they became very successful, and at one stage in their evolution were featured on German television. And once that happened, big institutional financial organizations began to get interested. So banks and insurance companies started looking seriously at what Market Maker had to offer. And Market Maker very quickly realized that this business of handing out weekly updates on a floppy disk just really wouldn't scale. So they reorganized around this merger, as they call it, product line, and the web as a delivery mechanism. So now instead of waiting for a weekly update to your portfolio, you can watch the decline of your German stocks in real time with the merger product line, because nobody's stock market has been doing particularly well these days. And then finally there's Nokia. And Nokia is, it's a classic case of how expectations and technologies have changed over the time that we've been doing this whole area of product lines and domain analysis and domain engineering. Because in the early days of the domain engineering work that I did, we used to tell people that your best chance for success with reuse is in a domain that's stable and mature, with well-published standards, well-published, well-understood terminology, and is changing only slowly, like telephony. Well, how times have changed. And in fact, most of the people in the telephony business are now in the video streaming business. And in addition, cell phones and personal communicators are a teenage fashion statement, and who wants to be in that market? And yet Nokia has succeeded handsomely in this market. They've been able to cover this amazing range of variation in the kinds of products they build. In fact, we had one of the Nokia architects come to our product line conference and talk about how they're able to support this and how they're able to have an architecture supporting this range of products and this range of both commonality and variability. So they have done very well using this whole approach of a software product line for the products they build. So all of these organizations came to the realization that they could create a set of reusable artifacts that would support the development of multiple products in parallel, and that they could get away from the old way of doing things, which is take a particular product for a particular customer and then tailor, mutate, hack, whatever, that product for the next customer or for a different customer in a different market segment. So rather than being an organization that is constantly trying to take what was known from a previous customer and anticipate what the next customer might need and hack that, being able to create the organizational structure and have the organizational process discipline to stand back from that and look at treating a line of products at a time as a contributor to the organization's bottom line business. And this whole idea of product lines has been around for quite some time. In fact, the first entry there dates back to about the 12th century, where you had the state architect who had not only a standard set of building designs, but had a standard set of designs for elements for how those buildings were to be created, whether they were official buildings for official functions or state residences or whatever. More recently, we have things like the IBM 360 family, and the Airbus family in particular is an interesting one, because one of the benefits that they got out of that, in addition to saving on the manufacturing costs of a common cockpit approach, the common cockpit also allowed their customers to save on training and maintenance costs. And of all the things we could have chosen to represent graphically, we chose what I think of, for those of you who are familiar with the patterns movement, I think of this as a representation of the cholesterol factory pattern. And the less said about that, the better. So as I said, there's been this gradual evolution from the earliest days of treating reuse as a technological approach to this more business-oriented approach that combines a technical strategy and a business and managerial strategy. And so this is a perfect time for anybody who is serious about reuse to seriously consider the benefits of creating a software product line. What is a software product line? This is the SEI death by text definition of a software product line. So let me parse this definition for you. First of all, a software product line is a set of software-intensive systems. So right there, the idea that there's a set connotes that you can identify what's in that set. There are some criteria for set membership. You know what's in the set, and you know what's outside of the set. And this set is characterized by having a common managed set of features. So there's going to be a degree of commonality across this set. There's going to be a range of allowed variation, and you'll be able to distinguish the members of the set by the deltas in the variance. But the overall set membership is determined by the essential commonality that every element of the set shares. So you have a common managed set of features, and these features satisfy the needs of a market segment if you're a commercial organization, or a particular mission area if you're a government organization. And if I stop at that point there at the market segment or mission. Up to there, you have what I would call the marketing definition of a product line. And I could create a set of software-intensive systems that looks like a line of products or a family of products, but that wouldn't share any resources at all. I could do this by having different parts of the organization create individual products that look as though they're related to each other, but there's no sharing of resources, there's no process discipline, there's no maturity in the kind of artifacts that are being reused within each of these efforts. So the SEI definition adds this additional restriction that these products are developed from a common set of core assets, and they're developed in a prescribed way. So there's a conscious decision to reuse these core assets across the set of products, and they're going to be put together in a disciplined fashion. And a lot of the prescription comes from the software architecture. The additional discipline comes from what we call the attached process that goes along with each of these artifacts. So for every reusable artifact that you create in your core asset base, there is what we call an attached process. That's the guidance for the product builders for how to take that reusable artifact from the core asset base and incorporate it into the product that you are building. How do you take a set of reusable requirements and match that against the requirements for a specific product that you have to build? How do you take a reusable architecture, a product line-wide architecture, and instantiate that as a product architecture? That's the attached process. And it's incumbent on the people creating these reusable assets to create that additional guidance for the people who are expected to use that in product building. So that's our definition of a software product line. And every product that you create in this product line is a product that exists for business reasons and is built using and reusing the expertise that you have available in your organization. So most organizations come to product lines by having an existing set of products in the marketplace already, and they want to rationalize their development processes around those products as a product line. So they have an identified set of business goals, and they have the necessary expertise within the application domains that they require to build their products, whether the application domain is healthcare products or radar systems or spreadsheets or shipboard command and control systems. You have the necessary domain expertise, and you have products to address the business goals within those areas. The products all share an architecture, and the products are all built from components or services that populate that architecture. But going down vertically from the business goals to the components and services, and in particular those of you that have been through the architecture courses will know that there's a connection between the architecture, between the structure of your software and the business goals you establish for the products that you build. So if you want to build products that are supposed to be flexible or customizable, whether or not they are flexible or customizable will be determined by how well you've done the partitioning of the elements in your architecture. So you will also be required in a product line context to evaluate your architecture for fitness of purpose. So when you say our business goal is to produce high performance products, what does high performance mean? Are we talking about throughput? Are we talking about latency? So you need to attach some operational meaning to those kinds of goals, and you need to make sure that your architecture either enables or does not preclude the kinds of goals that you are setting for your products. So there's a connection between the structures you place on your software and the business goals of the business goals that were set for your products. And the architecture and the components are examples of core assets within a product line. They're not the only examples. Here is a longer list of the kinds of things that can be made reusable across a set of products. So in addition to the architecture and the components, there are things like requirements. If you're going to understand the requirements for an entire line of products, you ought to be capable of distinguishing what are the common requirements and what are the variants for specific products. And you ought to be capable of treating the common requirements as a reusable asset across the product line. Similarly, if you've done any performance engineering modeling, like rate monotonic analysis, for example. Has anybody heard of rate monotonic analysis, RMA? I know Bill has. Mike has. This is a way of reasoning about the schedulability of a set of real-time tasks using a mathematical model. That kind of model can be parameterized for reuse across a range of products with a range of real-time requirements. So don't think of this as something that you apply to a specific product and not to all of the other products in a product line. This can become a parameterized, reusable asset to support a product line. Similarly, reusable documentation, whether it's internal documentation for developers or end-user documentation, that can be parameterized in the form of templates. So any artifact that can be made reusable is fair game for inclusion in the core asset base. Now, in practice, depending on the amount of money you can devote to this and the number of people that you can devote to this to get your product line up and running, you will have to make some choices about which items are we going to go after first. And most organizations focus first on creating a reusable architecture and a reusable set of components to populate that architecture. But don't neglect some of these other artifacts as well. So when I talk about the core assets of a product line, I'm not just talking about software, and that's something to bear in mind. There are many non-software artifacts that can be reused across a line of products. So you're trying to reuse as many artifacts as you can across the entire life cycle. The whole idea of creating a product line is to, first of all, create a set of reusable assets. These may be created initially if you are totally new to product lines and you don't have any reuse or any existing artifacts that you can base a product line on. But in practice, what most organizations do is they have a set of products in the marketplace already, and they recognize opportunities to abstract a set of reusable artifacts to support the development of those products. So they realize that why do we have this duplication of effort across these different products? There's at least a core set of components or a core set of services that we could capitalize on for reuse across that set of products. So some of the artifacts that you will create for your asset base include things like the architecture and the components, and the set of products that you create from those artifacts, the set of products in a product line will be built to be within the so-called scope of the product line. This is that set of software-intensive systems that you have identified and documented within the product line scope. And every product that you create in the product line is there because there's a business justification. A business case has been made for why you should be creating a set of products as a product line in the first place. And then for every proposed customer development project that comes along, there's a business rationale to be made for including that in the product line or not. And by the way, when I talk about software product lines, I don't mean that everything that you create has to be a member of the software product line, but certainly the goal will be to try to reuse as much as you can across the set of products and to treat them as a product line. But in practice, for some customers, they may require products that are really not part of the product line, but on the other hand, you don't want to turn them down just because it's not a member of the product line. This customer may be strategically important to you, and you may hope to do business with that customer at a later stage, so you don't want to lock out any business from that customer in the future. But for whatever reason, you may decide, okay, we will build you this product, but it'll be outside of our product line. But overall, the goal is to try to get as many products as you can built within the context of the product line and built from the assets in the core asset base. And so when you set up the core asset base, whether it's something you create from scratch or whether it's something that you create by abstracting from an existing set of products, you really need to think about the middle circle here. How are you going to produce those products from what's in the core asset base? So you need to think seriously about your overall production plan. If I have an abstract, generic product line architecture over here in my core asset base represented as a set of diagrams and associated notation, and the end target down here is a specific product running on a Wintel platform or a Linux box, what's the path from here to here? So your production plan gets into the overall process for how you take this reusable asset and then implement it in a particular language and use a particular development environment and a set of tools and a certain level of process discipline to create the desired end product. And because you'll be creating a range of products that are basically deltas off the common baseline, you need to have points of variation in your architecture to support that range. So your architecture is for the entire line of products, and any particular product is an instantiation of that product line architecture, and it's an implementation in terms of the target languages for the particular user or the particular market segment you're going after.